Okay, hi everyone. So let's talk about transformations of reciprocal functions. So reciprocal functions have the form y equals 1 over x, where x does not equal 0, because that's where it's undefined. It's not going to work, right? So this was our parent function of reciprocal functions, which is y equals 1 over x, just like in the name reciprocal, meaning flipped, so it's 1 over x. Okay, so we have now, if I want to transform this function, it's going to have the form f of x, so transformation, so let's say we transform it, and f of x is now equal to a over x minus h plus k. Alright, now, let's talk about what happened here. A is a value, alright? This time it's not 1, it's a. Okay, then x is here, but this time x, we're taking h from x, all right, so we're subtracting an h value from x, and then I will add k to the whole thing. All right, so now, we kind of have an idea of what's happening. So this is a transformation, or the possible transformations that can happen to a reciprocal function, to the parent reciprocal function. So a represents the orientation or shape. All right, let me write a to the side here. So a represents orientation and shape. Okay, so if our a is less than 0, then this means that it's reflected about the x-axis. Reflected about x-axis. Okay, now what if, alright, well not what if, but let's say the absolute value, and of course if a is positive, then it's going to stay the way that it does for an y equals 1 over x function, right, like the parent function. But if it's less than 0 reflected, there's a reflection about the x-axis. Okay, so now let's talk about the shape. What happens to the shape? So take the absolute value of a. If it's greater than 1, right, meaning you have 1 point, well not 1, but maybe 1.5, 2, 2.5, 2.77, or 101.77, and you keep going on, anything bigger than 1, then we have a vertical stretch. Okay, now if our absolute value of a, now we're looking at the absolute value of a because it matters, all right, so it works for negative numbers and positive numbers. Okay, and it's in between, so let's say our absolute value of a is in between 0 and 1, meaning we have a part of 1, okay, so it's like 0.05, 0.06, even negative 0.05, right, because it's the absolute value of a that we're looking at. Then now we're looking at a vertical compression. All right, okay, so this is a, we talked about a, now let's talk about h. All right, so let's go ahead. This was the A. Let's box each one of them. All right, and H, we have, this describes the horizontal translation. So it's the horizontal shift. Okay, so it's just like our previous graphs of transformations, H usually does denote horizontal shift. All right, so you can think H horizontal. And let me go ahead and box that. Okay. All right, so horizontal shift. So if H is positive, right, so meaning that x minus h is valid, like you still see the minus sign in front of h in your x minus h over here. So if h is a positive number, then you move h units right. Move h units right. Okay, the graph is shifted h units right. Now, if h is negative, then you will move the absolute value of h units left. Right, because I don't want you to move like negative 2 units to the left. That doesn't make sense. You move the absolute, because h is the distance. Right, you want h, and you want it to stay a distance. That's why we say the absolute value of h. Okay, so the absolute value of h units to the left. And that in itself is denoting that you are going in like the negative direction. All right. Okay, so that's h. And let's talk about our final value left to talk about, which is k. And k, as we've seen in our previous transformations, or if you're familiar with other kinds of transformations, k usually, and most always, denotes that it's a vertical translation or a vertical shift. All right, so you can, for like a linear equation, it's like the k, right? So it's like your y-intercept. But here we have a reciprocal function. All right, so k, it represents the vertical shift, not necessarily always your intercept for reciprocal functions, because reciprocal functions, as we said earlier, the parent one does not have any intercepts. Okay, so be careful. It helps to graph it first and then check to see if you have an intercept or not. All right. So if k is positive, then you move k units up. Okay. Now, if k is negative, then you would move the absolute value of that k units down. Oops, units down. Alright, okay, so I want to add on that if your vertical shift, right, your k changes, then your horizontal asymptote also changes. So I'll also write out here horizontal asymptote, okay, writing faster than I think, okay, is now f of x is equal to y, which is equal to your k value now. And for our horizontal shift, if our graph is transformed and we have that horizontal shift, then your new vertical asymptote, all right, that is now x equal to h. Okay. So I want to talk about the transformations of reciprocal functions. So I have the parent graph here on the left. All right, so this is our parent function. And I want to compare it to the transformed function. So the transformed function. Okay. All right. So here's the transformed one parent. As you can see, we have the horizontal asymptotes at 0 and vertical asymptote at 0. So x equals 0, y equals 0, and this is the shape that we have for y over x. But for our transformed function, you see that my a value, so let's go ahead and write that with a different color. My a value is now 3. My h value is also 3, all right? That's positive 3. It's x minus 3, but it's actually, in fact, h is 3 because the formula says x minus h. So h stays as it is, all right? And then the 4 is my k value, okay? So what happens is I have my a, 3, all right? It's positive, so there is no reflection happening about the x-axis. You see, it's kind of keeping the same shape as the parent function is. Those same curves, all right? So, but what's happening is since a is equal to 3, right? 3 is bigger than 1, so 3 is it's a vertical stretch is happening. Now let's look at our h. It's x minus 3. H is positive, so it's going to the right 3 units. As you can see, our graph has now shifted to the right as opposed to the parent function. And then finally, k is equal to 4, meaning that I have shifted my graph up to 4 units. You see, it's now shifted up, and we actually have like a y-intercept and an x-intercept happening as well. All right, so I wanted to also show you the graphs so you could see the comparisons between the parent and a transformed function. All right, and a transformed function can take on different, the a can change, h can change, and k can change. But this is one instance that I wanted you to see.